the next stage, which is graphical representation, histogram, block plots, and scatter plots. If you look at what we did before, we actually added histogram to it, and it helps us to display the distribution of continuous data, okay, which helps us access the symmetry, skewness, and modality. E.g., we saw the unimodal and the bimodal. We also saw other things that we can use the histogram to do, useful for detecting normal versus non-normal data. And then we've seen how to do it using exploratory data. But if you don't want to use exploratory data and you just want to use a singular command prompt, that's when you go through this Minitab path and then you do graph, then histogram. All right? We're not going to do that now. That's just a very simple thing, because we have a bigger thing ahead of us to look at. Okay, so block plots is also already visualized during our exploratory data. It helps us to summarize distribution using portals and also show media, interquartile range, outliners, etc. So now, this is the path for also bringing out the scatter plots. Just clicking graph and then you have scatter plot. But like I said, we are not doing this as an exercise because we have something bigger to do. All right. So the use case for histogram, we can have histogram of tensile strengths to check if the data are normally distributed. We can have box plots comparing policy impacts, okay, across different regions. You can also use scatter plots to show the relationship between, for instance, CO2 emission versus industrial output. So as the things that the use case example for this graphical representation. Okay, so we believe that participants now understand the types of data they are working with. You can now see how to summarize the data using statistics and Minitab tools. You can understand how to visualize trends, differences, patterns, the purpose of exploring data before modeling or drawing conclusion. Okay, so the next section now, okay, we will now delve into design of experiments. This is one of the major reasons why we are here. We want to see a structured approach to conducting experiments that review relationships between multiple factors and responses. So design of experiment DOE is a structured statistical approach to planning, conducting, analyzing, and interpreting control tests to evaluate the factors that influence a particular outcome or response. So why does it matter? It enables systematic investigation of multiple variables simultaneously. It enhances statistical efficiency, reduce the number of required experiments. Okay. It also identifies interactions with factors, that may miss. It supports data-driven decision making in science, engineering, medicine, policy, etc. So it ensures robust, reproducible, and optimized results. So in both scientific and policy environments, DOE helps to uncover cause and effect relationship, enabling better design of processes, interventions, and recommendations. So we're going to see the real-world relevance of DOE, okay? So DOE is used widely in both scientific research and policy formulation for offering valuable insights where control test is possible, okay? Scientific research is also used in policy context, is used in engineering and manufacturing, public health, and so on and so forth. In conclusion, we can see that DOE actually bridges the gap between theory and real-world applications by uncovering what works, how well it works, and under what conditions does it work. All right. So we want to see the overview of DOE types. We have the full factorial design, okay, which investigate all possible combination of factor levels. So if you say you're a statistician or you want to apply statistics or you want to use Minitab and use its tools to inform your scientific research or policy. So you can either use full factorial design, okay, which helps you to have substitute, which is suitable for small scale experiment with few factors. Okay, it offers complete information about main effect and interaction. For example, you can be testing 3 drugs dosage at 2 frequency levels. All right. So if you do that, you're going to have a full factorial design. You're going to have 2 times 3, that's 6 treatments. Another kind of design in DOA is fractional factorial design. Okay, this examines only a subset of the full factorial design, saving time and cost. Example of this is Bosboken that we're going to look at tomorrow. But today, our exercise will be based on full factorial design today. For the fractional design, it is ideal for early stage exploration or when testing many factors. Helps screen the most influential factor variables while sacrificing some interaction resolution. All right. So for this type of example now, let's say you're studying five factors with 8 runs. This will be to have about 32, runs. Okay, in a full factorial, they're going to be having just 8 runs. Okay, they are studying just 5 factors. They're going to be having just 8 runs rather than having 32 runs. So you can see that it's cost saving. Other ones are randomized block, okay, which is used in testing fertilizer types across multiple farms. We also have screening designs from Plaquet's Boomer. This is efficient for identifying main effects from a large number of factors, which assumes interactions are negligible, focusing only on individual factors. This is ideal when many variables need rapid elimination to narrow down important ones. So the example is in screening 11 formulations ingredients with only 12 experiments. So now, we now have our case example. So let's go back to our Minitab. Okay, we'll soon be having something in our Minitab, but quickly, we want to have a case example on this DOE, what we can use it for. So the case I have chosen is experimental policy testing. Okay, let's assume the goal is to identify combination of taxes, incentives, and educational campaigns to reduce emissions most effectively. Okay, so you want to design a factorial DOE with levels of each intervention. Then the outcome you're expecting is you want to inform, okay, integrated policy decisions with optimal objective, so with optimal combination. You don't just want to do the, what's it called, the gas ghost method or the fire brigade method, just do things anyhow. What these things help you to do is help you to be systematic and help you to be unbiased in making your decision. Another example is industrial process improvements. You can use it in optimizing temperature, pressure, and feed rates for maximizing product yield. Okay, you can also use it. You can choose either full factorial or response surface design. Then maybe our outcome is we're expecting increase efficiency, reduce waste, guided by the data. So another case study is maybe we have looking at behavioral response to public health intervention for those in the public sector. Your goal might be to assess how message tune, platform such as radio, TV, social platform like Twitter, and so on, and the frequency, how they influence community health behavior. All right. So you might want to use randomized block design across geographical locations. And then the outcome you're expecting a kind of a data-backed communication strategies tailored to audience segments. So next up now, we want to explore how Minitab can be used, okay, to design, analyze, and visualize experiments involving response surface methodology. So are we ready for our hands-on right now? Okay. So okay, before I move to the hands-on, I want to quickly explain this. So in creating a factorial design in Minitab, we have majorly two types of design. We have the 2K and the 3K design. I want to quickly explain what they mean. Okay. So we will learn how to create two level. 2K means two level, while 3K means three level. Okay. Factorial. The K stands for factors. The factors that you are looking at. Like in the one I gave you in that other example, exploratory data that we did, there are about how many factors there? Who knows? Who can tell us how many factors we have there? I have to see if you are following.
Three factors.
In the ones I sent to us,
As in C1, C2, C1, C2, C3.
C3, C4, four factors. But you tried. Instead of three, instead of four, you said three. So you got 3/4. That's 75%. So there are four factors. All right. C1, C2, C3, C4. So that means K there is 4. Do you get? So if you are doing two level, it means that you are only going to have low and high, values, e.g., low and high temperature.
I don't understand, sir.
You have to pay attention first. We are still going to show you on the screen. Do you understand? I'm still going to show you in Minitab. But I want to explain this. So in the example I gave us before, we saw C1, C2, C3, C4. So how many factors is that, sir? 4. 4. So the K there is 4. Okay? So, and I'm saying that level here means if you are doing for the factors, 2 level means low and high. 3 level means low, medium, and high. Can you see my screen, sir? Mr. Kitule, can you see my screen?
Yes, I can't hear you, sir.
Can you see my screen?
Yes.
So for the 3 level, what does it mean? What does it mean? It means what? Low, medium, and what?
Recording in progress.
High. Okay. For the 2 level, you can only get low and high. You can't get medium. Okay. The K there represents the factors. Factors are the things you are testing, whether they are your response or they are your input design. You understand? Well, in this regard now, we need to make factors our input design. So now, let's go into Minitab. Are we ready?
Yes, sir.
So now,
Yes.
the first work we've done is this.
Yes, sir.
So we want to move to the next work now. So let's come here, start. Can you see? After start, you come to DOE. And after DOE, you come to... I don't know if I started recording correctly. So after DOE, let me check if I recorded. Okay, I'm recording. All right, so let's go. Who is talking now? Should I help edit those that are talking? I know how to do that, please. If you are not giving us,
let us all mute our mics, please.
It's causing distraction, and we are recording this to send back to you. You will not see here because you have already disrupted the recording. Mrs. Mercy Orenolu, you are speaking to us, but to someone else. You are speaking on the background. You are disrupting the seminar with your noise.
Please unmute everybody, sir.
To go there now,
everybody.
it will take my time. Let me just see. Let me look for it. But people that want to talk to us can actually unmute and talk to us. But if you are in a noisy place and you're not talking to us, you mute by yourself. Let me look for it.
Mrs. Ogochukwu, please mute your mic. Okay.
Okay, I think the person is now muted. Okay. So I'll come again. I want us to have the full factorial exercise. So I will show you everything. Please just come with me, okay? So here, starts. Okay, starts. You know, anything you want to do is we are doing statistics, so you come to stats. Unless you just want to do a few tests, that way you come to graph and just do a few tests. But if you are doing a few statistics, you come to stats. Okay. For the other one, we did basic and we went to descriptive statistics. But here now we are going to DOE. Okay. And we are choosing what? Factorial. Okay. And then we are coming to here. Can you see? Create what? Factorial. Can you see that?
Factorial.
Good. So here now, I want us to choose. How many factors do we say we have here? 4. Okay. But
We have 4.
4, good. But I don't want to follow this very exercise. That exercise is already gone. If you look at the table I sent to you, this is the second exercise now. It's inconsequential of the first table. Do you understand? Good. So now I'm going to choose 3 factors. Okay. Okay. Or should we just use 4? Okay, 4 factors. All right. So we're going to choose 2 level because that 2 level means we're going to have high and low. Do you get that? So now we now move to display design. Can you see what it looks like? Okay. Then you come to design. Okay. So then you click full factorial. Can you see that? Number of blocks, number of replicants. So number of what? Center block. You choose, let us choose 3 here. What are center blocks? Center blocks are the things that you use to check for consistency in your data. Okay. So I'm choosing 3 here. That means there will be 3 particular data or experiment that must repeat. The same experiment. I must repeat that very one 3 times. Do you understand? So that's what that 3 is for. Okay. And then I go to okay. Then I come here. Okay, I've done that. Then I come to factors. Now, for those that are saying they don't understand what that 2 factorial mean, what that 2k means that time, k there means factors, and we have picked 4 factors. You can see A, B, C, D. Then 2 there means low and high. So now let's decide what does this A represent. Should it represent temperature? Temperature, for instance. Then let this one represent what? Let me say this one represents water. Okay. Let this one represent, maybe I'm trying to follow my own experiment. Let this one represent starch. And let this one represent, maybe this one represents glycerin. Glycerin. Okay. I think I can make this one starch, and make this one to be vinegar. That's what is my experiment, vinegar. Good. So that's the name of the factors. And we are saying that the stuff are numeric. The values you have to put here are numeric. Remember, we thought about data types. So that's why I mentioned those data types. So when you're working on is numeric, if it's text, you change to text. But if it's numeric, you leave it as numeric. So the starch now, maybe the mass of starch, the mass, okay, of starch. Okay, maybe here is from maybe 5 low, then 20 high. Okay, so then maybe here water, maybe water is 50, and then here so maybe here we say volume of water. You can decide to put the unit. Okay, mu. Okay, so it makes sense to you more. All right, so are we following? So here, let's say 2, 3, 2, 3. Okay, so you will see what happened now. You click OK, and then you move to options. Let's check the options. So this will say do not fold. So you leave it like that. Then let's uncheck this randomize runs. Why do I want to do this? Because I want the experiment to follow themselves sequentially. Okay. Whether I use it or not, it doesn't matter. But just for us to have a visuals of what is going to generate. Okay. Are we following? Then here, results. So here is where you decide how your results should be. If you want a result to only be summary table, you say summary table. If you want a result to be summary table and alias tables, you choose that. But for me, I want my result to be everything. To be what? Summary table, alias table, design table, defining relation, everything. Do you get? So that's what I want. Okay. So then you click OK. All right. So after you're done with all of that, you can then now generate your what? Your full factorial design. You see how it looks like. Can we go? Are we good to go? Yeah, good to go. Can we see this? So this is a
Yes,
full factorial design for that experiment that you are about to perform. Okay. So this is a full factorial design for that experiment you're about to perform. If you check the next table 3.0 on the Word document I gave you, you will see that the lower and the upper bound data I gave you were used to plot this full factorial table. And then I have about how many runs? I have about 19 runs. I have about 19 runs. Can you see? Can you see? 19 runs. And then can you see how each of these experiments they have to perform? The first experiment means you measure 5 to 50 to 2 to 2. Yeah, 20 to 50 to 2 to 2. Do you get that? So this is what a full factorial design is all about. Then how do we continue to work on this? When you finish generating this, let's now assume that you now went to your lab and you now plot, you now perform experiment based on this, and you now get the first response. So response 1. Let's assume that response 1 is somebody give me any value. Yield. Okay, yield. Let's assume that is yield. Okay. I didn't measure yield in my own. So let me look for what I measure. Okay. I think I measured. Okay, I think I measured what's it called? Energy. Okay. So let's just say energy. Energy. So you paste it, you can paste it here. Okay. Let's say the next one you measure is, what's this? This is the weight. The weight of the mass of the bioplastic. So let's just say this is weight of product. All right. So let's just use these two data to explore what we have gotten, what we have done. Okay. So then how do you explore, how do you continue to use this data? How do you analyze this data that you have gotten from this experiment? Okay, so you now come here, come back to start, and then you come to DOE, full factorial, then you come to analyze factorial design. Can we see this? Analyze what? Factorial design. So when you come here, so then you will now be picking your responses. What are our responses that we have there? Who knows? What are our 2 responses that we have there? See them here now. Energy and what? Weight of plastic. And that's what we have here too. So you just pick it. Energy. Exactly.
Yes.
You can press down your shift. You click the second one too. And then you click select. All right. So then after doing that, you can check your terms. Okay, this is fine. You check this. You don't need that. Options. So you check graphs. Okay, now you have to say, what kind of graphs do you want? So for me, I want 4-in-1 graphs. All right. So, and I want regular graphs. So that's why I click that. Then you click OK. Or if you want individual plots, you can just select them. Do you see this? All right, that's individual plots. It will plot them one after the other. Okay. And then results. Simple table, expanded table. I want expanded table. Can you see that? Then, okay. Storage. How do you want to be stored? So if you want to show, if you want it to show fits, residual, so you click all of them, as many things as you want to check, effect, matrix. All right. So then you click what? Okay. Or let's check the graph. Okay, we have already clicked the graph. Then you okay it. Then you can see what your full factorial design is going to give you. Can we see this? Can we see this? This is the coded effects. All right. So you can see everything. You can see everything. So the exercise we are going to give you now is for you to do your own, just the way I did mine, to do a full factorial design on this data. I pick energy from serial number 1 to 19 because my data is longer than 19. I also picked weight of plastic from, that's the next column. Okay, the first column is energy, second column is weight of plastic. I pick it from 1 to 19 so that it can fit my data. I don't want to overfit it. Okay, so then I have all of this. I have all of this. Can we see the Pareto charts? Can we see the at 95% level of significance? Can we see the normal distribution? Can we see the histogram? So these are all the things that you would see if you do your stuff the way I did mine. Please, any question, please? Any question?
Factorial regression. Sir.
Ma?
It's not clear, sir.
It's not clear?
I don't know if there is.
I wish you can repeat everything you just said.
I should repeat it. Okay. I'll repeat it. I'll repeat it. But it's like some of us are not following. For those that are following, I'll repeat it so that they can pick it again.
We are here following it as a conference class.
Okay, sir. All right, sir. All right, sir. So don't let me judge then. Let me assume you are following. So let me start all over again. Please. I want to do this all over again. So should I just undo? Okay. Let me just start from here. Start. Can we see start? Then DOE. The lecture is on DOE. Look at the screen. The lecture is on what? DOE. Hands-on with Minitab full factorial DOE. And then it says create a factorial. We have 3D, we have 2D. What we are doing is 2D. Okay, the K there is just to represent the number of factors. So if you want to do 3D, that means there will be medium. But for 2D, it's just low and high. Is that clear? So that's what we want to do. And these are the steps that I'm taking you through. That's you click start, DOE, factorial, and you create the factorial. And we choose the number of factors, the type, blah, 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 and we replicate the what? The options. So that's what we want to do now. So I'll take us through it again. So let's go to start, DOE, factorial. Please, if you have your laptop, you can be following me as I'm doing it, or you can be noting it, then create factorial. Then I select what? 4. Okay, but you know, I've already done it already, so I will need to clean. Let me clean this page. Let me clean this. Let me do new. So are we good now? I have my new page now. So start, DOE, factorial, create. Then I'm going to level, then factors, we agree 4, and then we come to this, we just close that, design, then I choose full factorial, then center block 3, I want 3 to repeat, okay, then this, okay, factors, and now say let us choose what did I choose here? Mass of what? Mass of starch. Yeah. You can decide to put the units in front. Okay, I said gram. Here is what? Volume of what? Water. And that one is in mil. So the next one is glycerin. These are just factors that I'm using. You can use your own factor. This is based on the data that I have. Remember. Okay. Good. So now the types, they are all numeric. So I'll now come to the starch. The starch is 5 gram, the lowest I'm using, and I'm using 20 as the highest. I'm using what's it called? Water is 50 mil to 60 mil. I said this data are in the stuff I sent to us. They are in the material I sent to us in the Word document. All right. So if you put all of this, you have set your factors. Then you come to option, and then you uncheck randomize, because I want everyone to follow each other. And then you come to results, and then you now click this summary table, okay, and then you okay it, and then after that, you now do what? You will click OK. When you click OK, you will see this. Is this clear now? We have just 2 minutes to round up this section. Please, I want us to follow. So when you generate this, you have about 19 what? 19 runs. You see it here. This is your design table, your design summary. 19 runs, 4 factors, 3 center blocks, center points. You get. So you have basically 19 runs, 16 distinct data, and 3 same replication, so that you can use that to do what? To center points. You can use that to check for your error in your experimentation. All right. So this is how the experiment will now come. So if for instance, you are in a what? You are in pharmacy. I want to produce drug, and you are using 5 gram of starch, 50 ml of water, 2 ml of glycerin, and 2 ml of vinegar to combine together to produce this. All right. So this is your first batch. Second batch up to what? 19. Up to 19. Look at it, up to 19 here. Okay. Is that clear? Are we following? So when you are done, you now take the sample that you have to a lab to check for the energy consumed. You now check energy. Maybe you also want to check, you want to also weigh the mass of bioplastic. Mass of bioplastic that you have produced. That I said that you have 2 responses. There are more other responses that you may want to check. Do you understand? But for this class, we are checking those 2 responses. Then you now pick, and I say, let us pick this first one up to 19 here as our energy that we measured after we are done with the experiments. Then here is the bioplastic, weight of bioplastic, or weight of your vaccine. So depending on what you want to check. For me, I'm checking a produced bioplastic. So the weight is important to me. Your own, it might be just the energy, it might be the yield. All right. It might be something else that is your response to this design that this Minitab has created for you. All right. So after that, and I'll say you come back to start, then DOE, then factorial for us to analyze. We want to analyze this what? This full factorial. Then when you want to analyze it, it will not ask you what are the response that you want to select.